India today has 111 national waterways notified under the National Waterways Act, 2016. Until 2014, the number was 5. This change is often described as an expansion of river transport. In reality, it reflects a delayed correction to a deeper structural imbalance in India's freight system, the near absence of inland water transport despite India having large river networks. According to NITI Aayog's 2021 National Freight Report, India moves about 4.6 billion tons of goods every year across all modes. Freight logistics costs are estimated at around 14% of GDP, and the sector employs roughly 2.2 crore people. This makes freight transport one of the largest economic systems in the country. In systems of this scale, even small efficiency gains matter. A 1 percentage point reduction in logistics costs translates into tens of thousands of crores in economy-wide savings. The relevance of inland waterways begins with basic transport mechanics. Moving heavy cargo over water requires less energy than moving it over land. This advantage shows up directly in operating costs. Figures cited by the Ministry of Ports, Shipping and Waterways, drawing on World Bank studies, estimate operating costs of roughly 1 rupee and 20 paise per ton-kilometer for inland waterways, compared to 1 rupee and 40 paise for rail and 2 rupees and 28 paise for road for the main transport leg. These figures do not represent door-to-door logistics costs. They exclude first-mile and last-mile trucking, terminal handling, and inventory delays. But they explain why, globally, bulk freight shifts to water wherever navigable systems exist. This advantage is why inland waterways are suited primarily for coal, cement, fertilizers, food grains, steel, iron ore, fly ash, and petroleum products, cargoes that are heavy, low in value per unit weight, and not highly time-sensitive. Despite this, inland waterways were marginal in India for decades. In FY 2013-14, total cargo moved through inland waterways was only 18.1 million. This has increased to 146 million tons by 2024-25. Over 12 years, an increase by 7 times, but not yet enough of what India requires. At the same time, road transport dominated freight movement. The NITI Aayog freight report shows that roads accounted for about 71% of freight traffic, rail around 18%, with the remaining share split across waterways, pipelines, and air. Inland waterways by themselves accounted for well under 2%. For a country with river systems like the Ganga, Brahmaputra, Godavari, and Krishna, this outcome was not geographical. It was institutional. After independence, transport planning prioritized railways for national integration and roads for access. Roads connected villages, towns, and constituencies. They delivered immediate, visible connectivity and economic activity. Rivers required continuous dredging, navigation aids, river training, and seasonal water management, investments that are long-term, technically complex, and largely invisible. This difference in visibility mattered for political and administrative prioritization. Institutionally, the bias was reinforced by federal structure. Water is a state subject, while navigation and trade require central coordination. For decades, no agency had both the authority and the funding to treat rivers as national freight corridors. The Inland Waterways Authority of India, created only in 1986, remained under-resourced for much of its existence. Even the original 5 national waterways saw limited development. The legal reset came in 2016, when Parliament passed the National Waterways Act, declaring 106 additional waterways as national assets. This did not make rivers navigable overnight. It changed jurisdiction. Once a waterway is national, the central government can fund dredging, build terminals, install navigation systems, and enter long-term cargo agreements. Without this legal status, inland navigation cannot function at scale. The most concrete outcome of this shift is the Jal Marg Vikas project on National Waterway 1, the Ganga corridor between Varanasi and Haldia. Supported by the World Bank, the project has a reported cost between 5,000 rupees and 5,400 crore rupees. Its design parameters are explicit: assured drafts of 2.2 to 3.0 meters, vessel sizes of 1,500 to 2,000 tons, multimodal terminals at Varanasi, Sahibganj, and Haldia, and digital river information systems enabling traffic management and night navigation. As these elements were built, cargo volumes increased. According to the Ministry of Ports, Shipping and Waterways, operational navigable length expanded from roughly 2,716 kilometers to about 4,894 kilometers. However, the limits are clear. Out of 111 notified waterways, only about 30 to 35 are currently operational or partially operational. Many are seasonal, some lack sufficient depth, others face environmental or economic constraints. Rivers are not canals. Water levels fluctuate. Sediment shifts continuously. Dredging alters river morphology and ecology. On rivers like the Brahmaputra, seasonal depth variations can span several meters, making year-round navigation technically complex and expensive. This is why global inland waterway systems concentrate investment rather than spreading it thin. In the United States, inland waterways carry roughly 10 to 12% of domestic freight, maintained continuously by the U.S. Army Corps of Engineers. In Europe, rivers such as the Rhine function as industrial freight backbones integrated with ports and manufacturing clusters. In China, inland waterways, dominated by the Yangtze system, carry over 15% of total freight. Closer to India, Bangladesh provides a relevant comparison. According to World Bank and Bangladesh transport assessments, inland waterways accounted for about 16% of freight transport in 2005, down from high levels in the 1970s, but still far above India's share at the time. Bangladesh maintains a waterway network of over 3,800 kilometers navigable in the dry season and nearly 6,000 kilometers during monsoon. Bangladesh has also sustained institutional continuity through the Bangladesh Inland Water Transport Authority, supported by World Bank financing exceeding $300 million for regional waterway projects. The system has declined over time but was never abandoned. Where inland waterways function, the benefits are concrete. Bulk logistics costs fall. According to government logistics reviews, public sector firms such as NTPC have used river-rail combinations to reduce coal transport costs on specific corridors. Long-haul trucking pressure on highways declines, reducing fuel consumption and congestion. The trade-offs are equally real. Road transport operators face competition on select routes. States remain sensitive about control over river resources. Environmental impacts require strict thresholds and continuous monitoring. This is why inland waterways are not a replacement for roads or railways. They are a specialized layer, designed to absorb the heaviest, least time-sensitive cargo over long distances, freeing other modes for higher-value movement. The policy challenge now is execution, not declaration. The NITI Aayog freight roadmap explicitly calls for intermodal integration and modal shift to reduce logistics costs from 14% toward 10% of GDP. Inland waterways are one component of that shift. That requires focused investment in 10 to 15 economically viable corridors, guaranteed cargo commitments, tight road-rail river integration, and non-negotiable environmental limits. India's National Waterways story is not about rediscovering rivers. It is about correcting a planning bias that ignored transport system for decades. The slow pace is not evidence that waterways do not work. It is the delayed cost of having never built the system properly in the first place. This is not a failure of rivers. It is the consequence of long underinvestment, and the outcome now depends on whether execution matches intent. If this helped you even a little, hit like and subscribe so you don't miss the next one.